This is how to balance combustion reactions. First scenario is when a combustion reaction works out evenly. So this is going to be scenario number 1, where it works out evenly. So now let's balance this equation. There are 5 carbons on the left side. There's only 1 carbon on the right. So to fix it, I need this to be 5 to match this 5 over here. So I'm going to place a 5 right in front of the CO2. That's going to give me 5 times 1 is 5 carbons to equal those 5 carbons there. Now there are 8 hydrogens on the left side. So over here, 2 times how many will give us 8 hydrogens on the right side of the equation? 2 times 4 is going to equal 8 over here. So that gives me 8 hydrogens on the left and 8 hydrogens on the right. Now, there are 2 oxygens on the left side of the equation. On the right side, we have oxygen in 2 different locations, here and here. So we're going to have to add all of these oxygens together. So it's going to go 5 times 2 equals 10 oxygens here, plus, and then this is going to go 4 times 1 is equal to 4 more oxygens there. And when you add 10 plus 4, you get 14 total oxygens on the right-hand side of this equation. So it's 5 times 2 is 10 plus 4, and together those equal 14. This, luckily, is an even number of oxygens, which means that over here, I need 2 times whatever this number is to equal 14. So 2 times 7 will equal 14, so that I have 14 oxygens on the left to balance with the 14 oxygens that we added up on the right-hand side. And now this equation is balanced, with this being an understood 1. We have 5 carbon, 5 carbon, 8 hydrogen, 8 hydrogen. 7 times 2 is 14 oxygen. 5 times 2 is 10. Plus 4 equals 14 oxygens on the right. Now this is scenario number 2, where we end up with an odd number of oxygens on our product side. And there's something special that we do when we have an odd number of oxygens. So we're going to start by balancing the carbons. 3 carbons on the left, 1 carbon on the right. So I need to fix it by making this equal 3, so it'll match the 3 over here. So we're going to put a 3 in front. That gives me 3 carbons on the left and 3 carbons on the right. Now there are 6 hydrogens on the left, so 2 times what is going to equal 6? 2 times 3 is going to equal 6 hydrogens on the right. Now there are 2 oxygens on the left. On the right, we have oxygen in 2 different spots, there and there, and we're going to have to add those together as a total. So we're going to have 3 times 2 is 6 oxygens here, plus 3 times 1 is 3 oxygens there, and 6 plus 3 equals a total of 9. This is an odd number of oxygens. So because this is an odd number of oxygens, we're going to do a special trick. We're going to take this odd number, the 9, and we're going to place it all the way over here in front of the oxygen in a fraction, 9 divided by 2. And what that does is 9 divided by 2 times 2 equals 9, which balances with this 9 over here. So now this is balanced with a 1, 9 over 2, 3, 3 ratio. However, we cannot keep this fraction. So to get rid of the fraction, we're going to multiply each of our coefficients times 2, and that's going to get rid of this fraction and keep the equation balanced. So my answer is 1 times 2 equals 2 C3H6 plus 9 divided by 2 times 2 makes these cancel with each other, and so I get 9 oxygens yields 3 times 2 equals 6 carbon dioxides, and 3 times 2 equals 6 waters. And now this is my final answer for this combustion reaction.